Find the second derivative of y is equals to ln x all over 1 plus ln x. Now let me put these questions to you. If you are given a function that looks like this, y is equals to a over b, what differential rule are we going to employ to differentiate such function? Yeah, we are going to use the quotient rule of differential calculus. So for this, don't forget that from our previous class, if we have a function like this, derivative of y is equals to v du minus u dv all over v squared. Hope you remember this from our previous class. Okay, let us proceed. Now let's take the derivative of y. If you compare this function with this function, you can see that this is u and this is what? V. So the derivative of y is equals to, we are going to take the derivative of u. Oh, sorry. We are going to from this formula, I first need v. And v is what? 1 plus ln x. So I'm going to have 1 plus ln x. Let me put this in brackets. Multiplied by the derivative of u. If you differentiate ln x, you are going to get 1 over x minus u. U is what? U is ln x. Let me add another bracket. Ln x multiplied by the derivative of v. If you differentiate 1 plus ln x, okay, let's take it one by one. Differentiate 1, you are going to get what? 0. So this is gone. Differentiate ln x, you are going to get 1 over x. So I'm going to have 1 over x here. All over v squared. V is what? 1 plus ln x. So I'm going to have all over 1 plus ln x squared. Please, I want you to pay attention. There is no magic in this. Just follow the process. You are going to understand. So let's proceed. Derivative of y is equals to multiply 1 plus ln x multiplied by 1 over x. I'm going to have, let me put this in the bracket, 1 plus ln x all over x. Do you understand? Minus ln x multiplied by 1 over x. That will give us ln x all over x. This all over 1 plus ln x raised to the power of 2. Now, the derivative of y is equals to 1 plus ln x all over x can be written as 1 over x plus ln x all over x. Because if you take the LCM, you are still going to get 6, okay? So it can be written as this. Minus ln x all over x all over 1 plus ln x squared. Do you understand? So from this now, we can easily cancel this out. This can be cancelled, such that we are going to be left with y, derivative of y is equals to 1 over x divided by 1 plus ln x raised to the power of 2. Do you understand? So the derivative of y is equals to 1 over x multiplied by, if this change to multiplication sign, this will come down. So I'm going to have multiplied by 1 over 1 plus ln x raised to the power of 2. So the derivative of y is equals to 1 all over x all into bracket 1 plus ln x raised to the power of 2. So having gotten the first derivative of y as 1 over x into bracket 1 plus ln x squared, let us take the second derivative. If I may ask you, which rule are you going to employ to differentiate this function? Yeah, you are going to make use of the quotient rule. And according to quotient rule, the numerator is u and the denominator is what? V. So let's proceed. From the quotient rule, I'm going to multiply v. V is what? Open a good bracket. X into bracket 1 plus ln x raised to the power of 2 multiplied by the derivative of u. if you differentiate a constant will give us 0. So I'm going to have multiply by 0 minus u is what? 1. So open a good bracket, 1 multiplied by the derivative of v. I want you to pay attention here. Multiply by x into bracket 1 plus ln x squared derivative all over v squared. V squared is what? X into bracket 1 plus ln x raised to the power of 2 squared. Please, I hope you understand what I did here. Look at this. I have 1, which is what? U is 1, multiplied by the derivative of v. The reason why I put this here is because I'm going to take the derivative of what is inside this bracket now. Are you getting it? So let us isolate this bracket. Let A is equals to x into bracket 1 plus ln x raised to the power of 2. I want to take the derivative of what is inside this bracket now. Are you getting it? Because the formula of quotient will it demands that I take the derivative of v. Are you getting it? So I want to take the derivative of what is inside this bracket right now. So I want you to pay attention. That is the reason why I isolate. That's the reason why I isolate what is inside this bracket. Are you getting it? I set A equals to what is inside this bracket. That is x into bracket 1 plus ln x raised to the power of 2. Now, let us take the derivative of this. If I may ask you, which rule are you going to employ to differentiate this function? You can see that we have two parts. We have the first part is what? X, and the second part is what? 1 plus ln x raised to the power of 2. Which rule are you going to employ? We are going to make use of the product rule first. Then I'm going to, using the product rule, this is u, and this is what? V. So I'm going to have, according to product rule, derivative of A is equals to u multiplied by derivative of v plus v multiplied by derivative of u. Are you paying attention? So u is what? X. So I'm going to have x multiplied by the derivative of v. I will simply differentiate v in this place. V is equals to 1 plus ln x raised to the power of 2. Let m equals to 1 plus ln x. You understand? I want to quickly differentiate v. Are you getting it? So v will be equals to what? M raised to the power of 2. So the v all over the m is equals to 2m. The m all over the x is equals to, if you differentiate 1, you're going to get 0. If you differentiate ln x, you're going to get 1 over x. So according to chain rule, the v over the x is equals to the v all over the m multiplied by the m all over the x. So the v all over the x is equals to, the v over the m is what? 2m. 2m multiplied by the m over the x is what? 1 over x. Multiplied by 1 over x. So recall that m is equals to 1 plus what? Ln x. So the v over the x is equals to 2 into bracket 1 plus ln x multiplied by 1 over x. So this will be equals to over x. Are you getting it? So I have differentiate v. The derivative of, okay, do you know what I did here is that I take the derivative of v. Don't forget that v is what? 1 plus ln x squared. 1 plus ln x raised to the power of 2. So I set v is equals to 1 plus ln x to the power of 2. And according to chain rule, we have to set a letter to the function inside the bracket so that we are going to make use of chain rule to differentiate such function. Are you getting it? If you have not watched my video on how to differentiate chain rule. You can go back to our previous class and learn it. Are you getting it? So I've not done anything here. Now let us proceed. I have taken the derivative of v as what? 2 into bracket 1 plus ln x all over x. So I'm going to have 2 into bracket 1 plus ln x all over x plus what is v? V is 1 plus ln x squared. I'm still using product rule. Hope you know. I'm still making use of product rule. So let's proceed. V is 1 plus ln x. 1 plus ln x raised to the power of 2 multiplied by the derivative of u. Derivative of u is what? If you differentiate x, we're going to get 1. So there is no need of writing that. So let's proceed. Derivative of a is equals to, now this will cancel this. I'm going to left with 2 into bracket 1 plus ln x plus ln, plus 1 plus ln x raised to the power of 2. Okay, I want you to pay attention, okay? Look, this is where this thing starts, Abi. This is the first derivative of this function. In order to take the second derivative, we make use of the quotient rule. According to quotient rule, we multiply v, which is the denominator, by the derivative of the numerator. If you differentiate 1, we are going to get what? 0. Subtract it, minus, then we are going to multiply the numerator, which is 1, multiplied by the derivative of the denominator according to quotient rule. So that is why I put this here. This indicates that I'm going to take the derivative of this function inside this bracket. So in order to take the derivative of this function inside the bracket, I set this entity, I set x plus x into bracket 1 plus ln x raised to the power of 2 as a. Are you getting it? So I take the derivative using the quotient rule. So that is how I got a. The derivative of a is equals to 2 into bracket 1 plus ln x plus 1 plus ln x raised to the power of 2. Are you getting it? So I have not done anything that you didn't understand. If you didn't understand, kindly watch the video again. You are going to understand, okay? So let us proceed. The next step now is that I'm going to substitute a and derivative of a. I'm going to substitute it into this place. Are you getting it? So let's proceed. The second derivative of y is equals to, if you multiply this by 0, this will be 0. Are you getting it? So let's move to the second aspect. I'm going to have minus into bracket 1 multiplied by the derivative of this is going to give us the same thing. So I'm going to have the derivative of a is what? 2 into bracket 1 plus ln x plus 1 plus ln x raised to the power of 2 all over this square, that is x into bracket 1 plus ln x raised to the power of 2 raised to the power of 2. As they so that is how to find the second derivative of ln x all over 1 plus ln x.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe. All questions are solved with simplicity.